All right, greetings everyone. Welcome to the third part of the video for section 6.3. Continuing on with our studies of the inverse trig functions, and we'll look at a couple more ways they can be used in this video. All right, so the first is to find angles in triangles. And so what we're going to do is use inverse trig functions to find the measures of the angles here in this triangle, the ones that we don't know. Now, we're going to use our calculators to do this, and most of the calculations I'm going to do off screen, but first I want to show us something important we need to pay attention to in our calculators. So when we're finding missing angles in triangles, we're generally going to measure those in degrees. We're going to use the inverse trig functions in our calculator to find them. Now, in order to do that, we need to make sure our calculator is in degrees mode. So in this case, we'll need to hit mode, go down to the line with radians and degrees, tab over to degrees, press enter. So now we're in degrees mode, and then we can work from there. So our answers now, or our calculators now, will give us answers in degrees instead of radians. So as an example, if I do second inverse tan of -1, which is one of the ones we did in the last video, notice it gives me -45 this time rather than the decimal we had before. So we see that that gives us an answer of -45 degrees. Okay, so let me go back to the PowerPoint. And we're going to find, again, the measures of the missing angles here. So we know already this angle right here, this angle C is 90 degrees, but we need to find A, the measure of angle A, and the measure of angle B. And the way we can do that is using inverse trig functions. So let me show you an example of that. So first of all, if I look at the information I'm given, so this side length of 12 and this side length of 13, and I look at them in relationship to the angle A. Well, hopefully you would agree with me that the side length of 12 looks to be the adjacent side to the angle A, and the side of length 13 seems to be the hypotenuse. So we have the adjacent side here, we have the hypotenuse here, so we know that that deals with the ratio of cosine. So we could set up an equation looking something like cosine of A being the angle there, is equal to the adjacent side, which is 12, over the length of the hypotenuse, which is 13. And then we need to somehow solve for the angle A. Well, I'm going to do this time, but we don't normally have to do this. But what we can kind of do is take the inverse cosine of both sides. So inverse cosine here. And on the left-hand side, the inverse cosine together with the cosine. We know that inverses, along with functions, usually cancel each other out. So we'd just be left with A here equals inverse cosine of 12 over 13. And really the moral of the story here is that we can find the angle A by doing inverse cosine of 12 over 13. So I'm going to do that in my calculator in degrees mode. And when I do, I end up with a measure of 22 in this case, to be 620 degrees for the measure of angle A. And now we can go on and find the measure of angle B. And to find B, there's a couple of different things we could do. We know that since there's 180 degrees total in a triangle, we've already got the measure of angle C being 90 degrees, so we know that A plus B would have to be 90 degrees. So I could do 90 minus the measure of A to get B. However, that can be a little risky since this measure I got for A is rounded off. So to avoid any rounding error, I'll actually just use an inverse function to help me find the measure for B. And I'm going to skip the initial steps I did with A and just set up the ratio for B. In this case, we want to think about how the side lengths of 12 and 13 relate to the angle B. And hopefully you would agree with me, the side length of 12 is opposite the side length of B, so that would be the opposite side. And the length of 13 is the length of the hypotenuse. So here we have opposite and hypotenuse, which we know relates to sine. So to find the measure of angle B, we can do inverse sine of that ratio, 12 over 13. Again, we'll do that in the calculator. And in this case, I get 67.380 degrees, which you should be able to see that if we add the 22.620 plus 67.380, that would give us 90 degrees. Okay? So that gives us, that's using inverse trig functions to find missing angle measures in triangles. Cool. And again, as a reminder, you want to make sure when you're doing these types of problems, or really any problem that involves using the calculators, you'll want to check which mode you're in first, whether you're in degrees or radians. All right, let's take a look at this now. So we're going to look at compositions of trig functions using inverse functions. And this relates to stuff that we do in PreCalc 1 that's of the type, like say f of g of 2. That was how we saw compositions of functions in that course. And you may remember that when we're working with problems like this, our approach is to start on the inside. So start with g of 2, and then work our way out. And so we're going to take a similar approach as we do these two problems I have here. So looking at the first one, we have inverse sine of cosine of 11 pi over 6. So I'm going to start on the inside at cosine of 11 pi over 6, which that's something that lies on the unit circle, right? If I think about my unit circle, 11 pi over 6 is an angle that lies on there. Sorry, I'm trying to get my writing correct here. 11 pi over 6 lies on the unit circle. It's in the fourth quadrant. And if we think about the cosine of the angle in that quadrant, cosine of 11 pi over 6 should be positive root 3 over 2. So we get that. And then now we have to evaluate inverse sine of root 3 over 2. And it's the inverse sine of positive root 3 over 2. So again, thinking about what we've talked about in earlier videos in this section, inverse sine only gives us answers in the first and the fourth quadrant. This root 3 over 2 is positive, which means we're working in the first quadrant. So we have to think about where is sine equal to root 3 over 2 in the first quadrant. And the answer there is pi over 3. Okay, so we get that there. And I want you to notice something that might be surprising on this is notice we started with the angle 11 pi over 6 and we took its cosine. Well, then you might assume that if we do the inverse sine there, we should just get the same angle back, right? Because we're saying, what's the cosine of this angle? Okay, we get the cosine, then we do the inverse sine, then maybe it should give us the same angle back. But it didn't happen. So that's something to keep in mind. All right. And this will also come into play in the bottom one here. So here we have inverse sine of 5 pi over 4. And we might think, oh, well, that will just cancel out these two, right? Which is kind of what I did in the last problem. So I'll be contradicting myself here a little bit. But let's work through this and see why that doesn't happen. So if we start on the inside with that sine of 5 pi over 4, think about our unit circle. 5 pi over 4 is in the third quadrant, and the sine of the angle there will be negative root 2 over 2. And now when we go to do inverse sine of that, well, again, inverse sine only gives us answers in the first or the fourth quadrant, so that already rules out 5 pi over 4 as being an answer. So you have to think where in the between those two quadrants sine will be equal to negative root 2 over 2, and the answer there is the fourth quadrant. And where in the fourth quadrant does sine equal negative root 2 over 2? Well, on our unit circle, that would be 7 pi over 4. But remember again, that the range of inverse sine is negative pi over 2 to pi over 2. And 7 pi over 4 does not lie within that range. But an angle that's coterminal with 7 pi over 4 that does lie in that range, well, that would be negative pi over 4, right? So if we rotate backwards, pi over 4 radians, we'll end up at an angle that's coterminal with 7 pi over 4. So that will be our answer there. Okay. Cool. That's it for now. Thank you for watching.